So we were discussing how to find the static payback period. Okay. So first, Y is the number of years just before the payback year. So here's the payback year is year 4, but it's not, we don't need to wait till the end of year 4. So A constitutes then the total remaining to be paid back at the start of break even year, which is year 4. So here we already discussed that at the end of year 3, the amount of money to pay to pay the investment is $5,000, because already the benefits at the end of year 3 is $9,500. So to pay back the initial investment, we just have $500 to reach 10,000. So we can consider then that A here is equal to $500. So A is equal to the investment minus the total net revenue at end of year Y, which is just the year before the break even. Now, during year 4, the total net benefit is $3,200. So just we can consider that just at the beginning of this year, we'll have the payback period. It's not 4 years, it's 3 point something, and it's much closer to 3 than 4. So to compute the static payback period, we just have to add 3 to 3 plus A, which constitute the amount of money that is remaining to pay back the 10,000, which is 500, over the amount of money that will gain during year 4. So over 3,200. So here approximately the static payback period is 3.156 years. Now from the table above, we can see that the payback period T is longer than 3 years, but shorter than 4 years. So without further information about when cash flow appears in year 3, we can assume that the payments are spread evenly within the months of the year. According to this assumption that we have linear variation, we can approximate the static payback period as Y plus A over B. Now, we are still in the approach of ignoring time. Another indication, if you want, when we ignore time, is to find the average simple rate of return on investment. What do we mean by this? The average simple rate of return on investment is the net profit per year as a ratio of initial investment. So we can consider for each year what is the percentage recovered from the initial investment. So for example, if a project makes an annual profit of $2,000 while the investment is $10,000, then for each year the rate of return will be 20%, because if we apply this formula, we just have to divide the annual profit, which is 2,000, by the amount of investment, which is equal to 10,000. And of course, larger is the percentage, the rate of return on investment, okay, better will be the economical viability of the project, because if we can pay back the, in this case, we can pay back the investment in a very short period when we have a high initial percentage. So here, for example, you can directly deduce that if it's annual, if the average simple rate of return, let's say, will be constant, then we can consider that in 5 years we can pay back our initial investment. Sometimes the annual profit will not be constant. Okay, so this rate can then vary for can vary for each year. You can have a certain rate. Now, so already we have seen some indicators as the static payback period and the average rate of return in case we have we don't take into consideration time. But as we mentioned, especially for energy project, it's not a good idea to not consider time, especially because in energy projects we have a large time if you have taken here the example of the lamps, the payback, the time, the lifetime, let's say, is in months. So you can consider that uh, if I just have a lifetime of 6 months, no need to consider a time effect. But if in case I have a project for which the lifetime is 50 years, it's not recommended at all to ignore time. So if we want to employ time, we have many new factors to take into consideration. First, we can calculate what we call the net present value. So all costs and benefits should be projected back to we can take them back to the start of the project, okay, to uh, to find what is the equivalent value of money of these incomes and costs if we are paying them now. Okay, so the net present value involves conversion of all benefit and cost streams occurring at different points in time to their present value equivalents and aggregating them to get the overall worth of the benefits and costs of the project. So, because the net present value will calculate the value of money at now, if you want, always for the investment, we don't have to take into consideration any variation because the investment is paid at the beginning of the project. However, with years, the revenue and costs will not have the same value if we project them now to the present. Okay, that's why we should take into consideration the discount rate. Okay, so we know that value of money will be reduced with time. That's why we should include a discount rate which will account for the reduction of value of money with time. And then we can consider that, let's say for any year, let's say for year one, the revenue and cost should be divided by 1 plus I to the power 1. While for year 2, I should divide by 1 plus I square, for year 3, 1 plus I cube, etc. So in general, the net present value is calculated as minus I0 plus the summation of RT, which is the revenue at year T, minus the cost at year T, over 1 plus I to the power T. And in this case, RT represents the revenue in year T, CT is the cost in year T, I is the discount rate, and I0 is the initial investment. And we'll see together how to account for the value of the discount rate, how to calculate it. Now, a variation to net present value, another approach also to study a project is to consider the ratio of benefit to cost. And of course, the benefit over cost ratio should be larger than 1. But here, the problem here is that we are not considering the initial investment. So it's not enough if you want, it's good to have a large benefit to cost ratio, but to know if it will pay back the investment during the payback period and the amount of gain that we'll have, we should always then include the investment in the analysis. Now, what is the financial appraisal discount rate? Uh, we'll discuss now how to take a value for the discount rate. So investors expect a return on their investment that would at least be equal to the rate of the interest that could be earned from similar investments elsewhere. Therefore, private investors usually use the market interest rate as the discount rate. What do we mean by this? When you want to invest your money, you have several options to invest in. You can put your money in a bank, you can invest in other projects. Okay, so to decide, you at least you should have a return that is equal or larger than the ones that you can earn from other investment. That's why we can consider that the value of the interest rate, okay, can be considered, or the discount rate should be selected as the market interest rate, because I should be able to to have a benefit larger than the one that I predict in any other investment in order to decide to go and invest in this project. Okay. Now, capital normally consists of a mixture of debit. And sometimes, for example, whenever you want to start a new investment, you can take external financing, you can take money from a bank, or you can use internal financing. So you can use money also from your own pocket. In this case, okay, we should pay attention how to calculate the discount rate, because you should take into consideration if you are using external financing, you should select a certain discount rate. If you are using your own money, or if you have a mixture, then you have a formula that can give you what is the discount rate to consider. So the debit interest rate depends on the capital market and is equal to the interest rate on the market that projects of the same risk category and similar repayment periods have to pay. So if you when we talk about the debit interest rate, we should look at the market, the capital. We consider the debit interest rate that is considered in the same category of risk. Yani you should take, whenever you select a project, you should look at similar projects in the market. And because when you do this, you can observe projects that are similar to yours are affected by which factors, what are the risks they can encounter, what is the corresponding discount rates that I should consider. Larger the risks, okay, larger the value of the discount rate. Okay, that's why we can consider that we need expertise when we select this rate. You have some experts in economy that studies the market for a long period of time. They can tell you this type of project is classified, let's say, under this category, so this is the discount rate you should select because you have nearly same risk effects. Now, and we'll talk more also about these issues when we talk about de-risking in future lectures. Now, the capital cost of equity is equal to the returns that an equity investor wants to see on his/her investment. So, in case you want to you want to invest your own money, you can expect uh, uh, a certain benefit that you will have. Okay, a certain percentage of gains that you will have. And so you can consider that once I invest this money, I will have this gain, and this will help you into selecting the value of the discount rate that is equivalent to the percentage of returns that you are expecting. So combining both cost of debit and cost of equity, this will yield to what we call the weighted average cost of capital. Now, let us see together how we can compute it. Okay. So, for example, if you want to calculate the discount rate, you need to determine what is the source of your capital. So, your capital can be 100% debit, can be 100% equity from your own pocket. So, you can, or it can be a combination. And you can have part from banks, let's say, part from your own money. And depending on these percentages, you will be able to calculate the value of A. So first, as we mentioned, if you have a debit, you should consider, as we mentioned, the value of market interest as percentage. While if you decide to use your own money, you should use the percentage that you expect to gain with this money in a certain investment. Okay, and then the overall value of the discount rate will be because you have here 70% of debit, you should multiply 70% by 5. So this is the contribution of the debit part in your discount rate times 5% plus the contribution of the money you are putting. So you should add plus 0.3 times 8%. And for example, here the value of discount rate is 6%, nearly 5.9%. Okay, and then you will use this value of I in your calculation. While if you are just you have 100% of debit, then your discount rate will be 5%. If you have 100% of your own money, you put the discount rate as 8%. Now, let us talk about some disadvantages of the net present value. So, as the net present value is relatively easy to calculate and reflects the time value of money, the NPV has a prominent place in energy economics. However, we have some disadvantages if we just take this method. Why? Because first, the value of the net present value will depend on the underlying assumption of the project parameters, which cannot be estimated with a certainty. So if we talk about the discount rate, okay, we have developed a method to calculate it, but it is never 100% accurate. You have always risks, so you have always subjective estimation. You need to take the idea of experts, but even you have a judgment from a person. It's not 100%. You cannot say that I can be aware of all possible risks. You can always have new risks that you cannot predict, or you can have any variation in the economy of your country, etc. So all of this can affect your results. Plus, the NPV is an aggregated value. It will calculate for you the net present value after a certain period of operation of your project. So it represents one aggregated value. In the end of the calculation, there is only one value that describes the economics of a complete project, which may have a lifetime over 30 years. This is why we should take care when we go over this method, and we can do what we call the dynamic analysis. So, no aggregated value can tell anything about the dynamics during the lifetime. That's why, okay, we need to come up with other factors that can help us into deciding to if we go through a project or not. We'll see this, for example, when we discuss the debt service coverage ratio. Now, how to calculate the dynamic payback period? So when we take into account time, of course, the payback period will change, and the dynamic payback period is always larger than the static payback period, because we know that with time we have a reduction of value of money, and because of this, the payback period will be larger in case we consider time. The dynamic payback period will always be larger than the static payback period. And how to calculate it? It's very similar to the concept. It's the same concept. The payback period is calculated when the net cash flow is zero. But now it's more complex to find it because this term, for each year, we should divide by 1 plus I to the power t. And now, if we consider, if you want, when we do this summation, in case RT minus CT is constant, we can take it outside of the summation and we can use geometrical series. If not, we can prepare like Excel sheet or do calculation by hand in order to find, as we did in the table before, to find the dynamic payback period. So in comparison to the static payback period, the dynamic payback period is longer, especially for your renewable energy project. This is because for renewable energy projects, we have no fuel cost. The initial investment costs are the largest cost component. We know that in renewable energy, operational cost, maintenance cost, and the costs afters will be much smaller, sometimes nearly zero. But you have a big initial investment to put. And because whenever we talk the dynamic payback period, the value of money is reduced with time, and since your investment you should pay it as you should pay the whole amount at the beginning of your project, this will lead to an increase in the dynamic payback period. And this is why, if you want, we should take care of economical analysis when it comes to energy projects, because one of the disadvantages is that we have a very high capital cost, and it's paid at the whole cost nearly is paid at the beginning of the project. So, as we discussed, because renewable energy projects have no fuel costs, the initial investment costs are the largest components. As they occur in year zero, they will not be discounted. So, the revenue, however, occurs in the future and is discounted. And this will lead to a longer dynamic payback period. So, if you do the analysis of this equation, the costs are really small whenever you take renewable energy projects, but the investment is really high. So you have a very high investment, and this investment is not discounted because it takes place at year zero. However, your incomes are discounted. So you have your revenues will be for each year. Let's say at year t, they will be divided by 1 plus I to the power t. So larger is your discount rate, you will have more risks, and the payback period will be longer and longer. Now, another factors that can help you in making your decision if your project is economically viable or not is the internal rate of return. The internal rate of return is the value of I for which the NPV at the end of lifetime is zero. Okay, so as the NPV calculation is dependent on the choice of the discount rate, an alternative method attempts to find the discount rate for which NPV is zero. What is the importance of this analysis? Let's say, for example, I uh, I want to do some parametric study. I want to implement a project. This project might be good to implement, let's say, in America, but not good to implement in Lebanon. Why? Because it depends on the value of the internal rate of return. The internal rate of return will give you an idea of the margin of discount rates you can work with while still and have a net present value of zero. And for example, if you calculate the internal return rate and you get 20%, this means what? This means that any discount rate below 20% will give you a positive net present value, because the net present value for 20% will be zero. And since smaller discount rates, okay, lead to lower discounted values in the future, this means that what will happen is that you can pay back in a shorter period of time, and then you can start to gain, and at the end of lifetime you will get a positive net present value. So once you find the IRR, the internal rate of return, you can find the margin of interest rate for which the NPV will be larger than zero. So you can say for any rate between 0 and 20%, then NPV will be larger or equal to zero. And it will be just equal for the internal rate of return, which is 20%. And of course, you will never design your system to just have net present value of zero. You need always to gain a very high percentage. And even in some cases, we define also what is called the capital enrichment rate, that say that in order to consider a project to be to have a benefit, we don't consider just it should have NPV zero. No, we should gain, and this gain should be at least 30% of the investment. So the capital enrichment rate is the NPV at the end of lifetime of the system over the initial investment I. And in general, we recommend it to be larger than 0.3. So we should gain at the end of lifetime at least 30% of our investment to consider that it's a good investment. And this is because as we discussed, you have a lot of risks that might happen. You can so to take into to be on the safe side, you should always take a big percentage here. So in case you have some unpredictable risks, you will still be able to gain at the end of your project. So here, uh, the internal rate of return is a good indication because it can tell us what is the range, or it can give us a range of discount rates to work with. So it can tell us that if you are in a stable country where the range is, let's say, 1 to 2%, the discount rate, you are very far from the internal rate of return. So of course you will gain a lot. And even if in risky countries, let's say in countries where in general the discount rate is recommended to be 10%, you can still earn money here. So having a large internal rate of return is a good indication for the project. While if the internal rate of return is small, this will narrow a lot the range you can work with. And if you have an internal rate of return equal to 5%, this means any discount rate larger than 5% will make your project not economically viable. You will lose money. Okay, so now in order to calculate the value of the internal rate of return, we set the condition that it is the rate for which the net present value at the end of lifetime of the system is equal to 0. So summation from 1 to n of revenue minus cost for each year over 1 plus the internal rate of return to the power t minus I0 is just equal to 0. The IRR will give the yield of a project relative to the required investment. So we mean what by yield we mean we cannot have a discount rate larger than the internal rate of return because we'll lose money. The IRR can be obtained using an iterative procedure within a spreadsheet. See, for example, the following. So you can develop numerical techniques. So in case, for example, you have constant rate, balance rate of income and cost. If this is constant, you can use mathematical calculation. Okay, and if it's not constant, you can then just do calculation by hand. Even when you do the geometrical analysis, okay, you can still have a term. You can solve analytically your equation or using the calculator. So if you use the analytical equation, you can use the calculator. Even this summation can be implemented in the calculator. So the calculator can solve for you such equation if this term is constant. If not, you should do like a iterative procedure in order to determine the value of the IRR. Okay.
دكتور شو بيفرق ال IRR عن ال discount rate؟
Okay. The discount rate هو the actual rate that you have in your project. Okay. And for this rate, you can calculate for any year what is the net present value. Okay. However, the IRR هو the value of the discount rate that will give you a net present value equal to 0. هيدا الفرق. يعني أنت
يعني
you set the net present value equal to 0, you calculate the IRR. Then once you find this value, you can say for any discount rate I smaller than the IRR, the net present value will be positive.
negative.
Positive. إذا I أصغر من ال من ال من ال من الريت اوف ريتيرن، اوكي، بتطلع positive ال NPV. ليه؟ لأنه أنت
yes
you are more
denominator.
confident. If I is small, you are more confident in future. يعني discounted value is smaller. يعني you are losing amount of value of money you are using is smaller. Okay. لأنه أنت you are dividing by 1 plus I to the power t. كل ما I صغيرة كل ما أحسن. Okay. So
Yes.
whenever you
Makes
find
sense.
the internal rate of return, you can say that any value of I, if you have I between 0 and IRR, this is good. Okay, because you will have a positive net present value. However, if you have I larger than the internal rate of return, then it's not good. Okay.
Yes. Thank you.
وحتى already it's not good to have I equal to the IRR. You should be far as much as possible. كل ما بعدت عن ال IRR towards 0, كل ما net present value will increase and the payback period will be reduced.
Okay.
Okay. So for example, okay, let us considering the following analysis. Okay, we want to make a decision, but we want to decide between two projects. Okay, so we have a firm that defines a required return on its investment, a preset threshold investment rate known as the hurdle rate. Usually, the hurdle rate, which is the IRR, is equal to the firm's cost of capital obtained by applying the WACC method that we discussed above. If the IRR exceeds the hurdle rate, the firm should consider. So here, by the hurdle rate, we mean they consider this is I. Okay, the hurdle rate is I, and we obtained this rate from what is the WACC analysis? This is the one considering if you want the percentages. So if I have 70% of debit, 30% of my own money, what will be I? Okay, so the WACC method will give you the value of I, and it will take into consideration the percentage of money from debit and the percentage of money from your own pocket to calculate I. Now, once you have I, okay, if you calculate the IRR for your project, you should make sure that I is smaller than the IRR to continue with your project. If it's larger, you say my project is not economically viable. I should redesign it. Yani I should or reduce the investment, or for example, if I'm designing a power plant and I want to sell electricity, I should increase the price, for example. I should try to increase the number of consumers. So I can have several strategies to make a project viable, economically viable. But at least this will help me when I calculate the IRR. I can see if I should go over new strategies or my project is fine as it is. So if the IRR exceeds the hurdle rate, which is I, the firm should consider the project for further investigations. While, as we discussed, while the project should be rejected if the IRR is below the hurdle rate, which is I. Okay. Now, uh, so here, this is the graph showing the analysis. You want to invest in a certain project one. Assuming two similar projects in terms of lifetime, risk profile, capital requirement, financing structure, and cash flow characteristics. If they are similar in all of these aspects, okay, but the IRR of project one is larger than the IRR of project two, which project will be better? So if you are comparing two projects, okay, if you have all factors common except the IRR, we said that larger the value of IRR, then you have a larger range to work with. Okay, you have a larger range of interest rate to work with, and then you can of discount rate, sorry, to work with. And then if you have a very big IRR, this means that if you are far from this IRR, the farthest you are from this IRR, the better is. So the project having the largest IRR will be the most economically viable, because you will have a large difference then between your actual discount rate will be much smaller than IRR. And if you have a large difference, this means that you can expect lower payback period, you can expect larger benefits, etc. So if you are comparing two projects of same profiles, they are very similar in several terms, but the IRR of project one is larger than the IRR of project two, of course you will invest in project one. Now, if you have one project and you want to decide if you continue with it, you do further analysis or you reject it, you can compare the IRR with the hurdle rate, with the discount rate. Okay, in case it is larger, you can continue with analysis. You can try if you want to do some strategies to enhance it more and more, or if you get IRR smaller than I and you don't have any strategies that can make the IRR larger, then you should say I should stop here and reject the project. Because if IRR is smaller than I, this means you will get a negative net present value, so you will lose money. So of course you will not invest in a project where you lose money. Okay? Any question on this? So the IRR is easy to communicate. However, what do we think can the problem with IRR when we compare two projects? Mainly, to be able to compare two projects, you should have all other factors the same, and only the IRR is different. In general, it's difficult to have completely same features of the projects, but in case it is the case, and in case you have different common factors, the comparison of the IRR can help you into making your decision. So we should have so problems arise when comparing two projects BC. It is difficult to get the requirement, but if we have similarity between the projects in terms of lifetime, risk profile, capital requirement, financing structure, cash flow characteristics, then we can compare the IRR to make a decision. NPV and IRR between projects can therefore be contradictory. What do we mean by this? Sometimes you can have, let's say, larger net present value. Okay, so if you compare the net present value, maybe you select project one. But if you compare between IRR, you select project two. This is because mainly you might not have the same lifetime. That's why to be able to compare only IRR, you should have the same lifetime. Okay, so make sure to have same characteristic to do comparisons, because if you have different lifetime, you might have a larger IRR. Okay, so you can, this is better, but a smaller NPV because the lifetime is different. So if two projects have different lifetime, for example, the IRR of the project with a short lifetime could be higher than the one with the project with a longer lifetime. But the NPV of the former could be lower than the NPV of the later. This means that the short time return of the firm's investment would be higher if the company invests in the shorter lifetime project, but the absolute value that is added to the company would be higher if the firm invests in the project that has a longer lifetime. So what we mean by this, if you go through a project that has a smaller lifetime, the payback period is relatively short. Okay, and you will gain money. You will gain money, and if you do, maybe the ratio of net present value to investment, it might be higher than the other option. But if you have a long time, okay, or a long time of operation, you might have in as absolute value, you will gain more because of the time of operation. Okay, in general, if you are sure that you will gain, you can allow for you can select the higher NPV even if you have lower IRR, because your project will operate for a longer payback, for a longer time. Okay, in general, when we do comparison, it's preferable to do the comparison with same features to be able to make the decision. In general, when we compare two projects, we compare two projects of same lifetime, because if we want to compare different lifetimes, we might have contradictory results, and then it depends on your priorities. If you don't wish to have a project for a long period of time, you have constraint of time, you are not sure if your industry will continue, let's say, for this long period of time, then you can go for the short time return and you will go for small projects. On the other hand, if you are sure that you are in a country that